Okay, go ahead and grab your journal from the bookshelf. This video is going to be a little bit long and there's going to be a lot of note taking, but it's a topic that you've already learned in 6th grade and I think will be really easy for you all and a quick review. So we're going to go ahead and start off with our definition of an integer. An integer is any positive or negative whole number. So examples would be -1, 2, 0, 40, -5, 10, etc. Non-examples are anything like 4.5 because that has a decimal and decimals are not included in an integer. Another non-example is -1/2. The fact that it's negative makes it somewhat of an integer, but fractions are not integers. So anything with a fraction or decimal is not considered an integer. A way to illustrate an integer is on a number line, right? So if I say to represent 5, I would go over 5 spaces, and that's how I would represent 5, right? Integers are anything that can clearly be seen on a number line. So you'll see on the white dry erase board wall in the iPrep room, we have that big number line at the top. All those numbers that you see highlighted there are integers because they are whole numbers that are both positive and negative. So that is the example of an integer. So the key is understanding what situations represent positive and what represents negative. So in this example, it says that an average temperature of 5 degrees below normal. So I know that I'm going to have 5 degrees, and the fact that it says below normal makes me think that it's below 0, and all numbers below 0 are negative. Next one says an average rainfall of 5 inches above normal. When I think of above, I think positive, so I'm going to write a positive 5. Some other positive words are profit, gain, earn, above sea level. Some negative words are loss, owe, perhaps you have a debt, you owe someone money, below sea level, etc. Below is one of the main indicators that it is a negative integer. So in this particular case, it says to graph the set of integers 4, -6, and 0. So 0 is always considered our starting point, right? And it's very clear, it's very easy to identify 0. So I'm going to go ahead and identify 0 on my number line. 4 is positive, and all positive numbers are represented to the right of 0. So I'm going to go over 4, and I'm going to represent a dot right there to represent 4. The next one is -6. Negative numbers are represented to the left of 0. So to find 6, I'm going to go over 6 spots to the left, and I will find myself right here at -6. So that was very easy in terms of labeling these numbers on the number line. You all should know how to do this on your own. Now, here are some tricky questions. So it says in part A, where do you begin when locating a number on the number line? Well, your starting point always is going to be at 0. Imagine at football, right? When you're playing football, you always start at 0. And then if you gain 7 yards, you're going to move +7. But your starting point, the amount of yards that you have in the beginning, is 0. So I'm always going to start my number line at 0. Counting up, when I count my numbers up, it means that I'm counting towards positive numbers. When I'm counting down, I'm counting towards negative numbers. Now, this particular slide you don't need to copy down in your journals. It's just for you to think out loud, or think to yourself, To understand, when I say count up, I'm talking positive, and counting down means negative. And it's super important for you to know that your starting point is always going to be 0. So then it says, what do you call the distance between a number and 0? So if I tell you the distance between -5 and 0, right? What is that vocab word called? You may remember this from 6th grade, or you may not. but that is called absolute value. Absolute value just measures the distance. It doesn't care if it's positive or negative, it just wants to know how far you have to travel. So if I ask you the distance between 0 and -5, how far do you need to walk to get to -5? The answer is 5. You only need to walk 5 steps, 1, 2, 3, 4, 5 to get to 5. It doesn't matter what direction you're going. It doesn't matter if you're going in the positive direction. It doesn't matter if you're going in the negative direction, if you're going north, south, east, or west. I just want to know how many times am I going to have to shuffle my feet to get to -5. And the answer is I'm going to have to move it 5 times. Now the last question says, what is the relationship between 4 and -4? Well, they are the same numbers, but the only difference is that they have opposite signs. So they are opposites. Now, the important thing to know about opposites is that they always equal 0. Imagine I give somebody $4 and then they spend it, right? How much do they now have? $0. So opposites are always going to equal 0. So let's go ahead and solve these problems quickly. Go ahead and pause the video, answer these questions in your journal, and then continue and hit play. So number 1 says, how far is 7 from 0 and in which direction? So I'm going to start at 0 always, and then I'm going to count to 7. So it's 1, 2, 3, 4, 5, 6, 7. My distance there is 7. And what direction? When I'm moving to the right of 0, I am moving into the positive direction. Now the next question says, what is the opposite of 7? The opposite of 7 is going to be -7. How do I know that? Because 1, all I have to do is change the sign. But let's think about it. If I have to move 7 places to the right to get +7, what would I get if I move 7 places to the left? 1, 2, 3, 4, 5, 6, 7. I would get a -7. So that's how we figure out what the opposite is by going in the other direction. And then it says, how far is -7 from 0 and in which direction? The answer is 7. We just solved that. So they are opposites because they're in the opposite direction. But at the end of the day, they have the same absolute value. Meaning, no matter if I'm going to 7 or -7, I'm still going to have to move my feet 7 times. So now this is where the important part comes in, where we start to model addition using integers. So make sure that you are paying close attention and writing great notes so that you can have this model in your notebook to do further problems. So let's start with 5 plus 2. You all should know how to add 5 plus 2 based on your old understanding of addition, right? We know that's going to be 7. Alright, hopefully we all know that. There are a number of ways for us to model these this particular example. So one way that I'm going to show you is using integer chips. So integer chips are these little round circles, and on one side it is yellow, and on the other side it's red. And the red and yellow, the red means it's negative, and the yellow means positive. So what we're going to do is actually model 5 plus 7 using integer chips. So let me go ahead and put a divider line here. But if I'm going to represent 5 with integer chips, I know that 5 is positive, so I'm going to put 5 dots. 1, 2, 3, 4, 5. And then I have also 2, so I'm going to put 1, 2, right? So now I have a total of 1, 2, 3, 4, 5, 6, 7 integer chips, and they're all the positive sign. So that's how I would represent addition of this particular statement using integer chips. Now, the other way to represent it is using a number line, right? So I know I'm always going to start at 0, and then what I'm going to do is I'm going to jump 5 spaces to +5. So 1, 2, 3, 4, 5. So now I landed right here on 5, right? That's me moving +5. Then it says I want to move an additional +2. So I'm going to move 2 additional spots. 1, 2 for an additional 2. So how many spots did I move in total? 1, 2, 3, 4, 5, 6, 7. So already I see all my answers panning out. I had 7 through the integer chips, 7 through my number line and using my old idea and knowledge of addition, I also got positive 7. So my answer here is going to be positive 7. Okay, let's do the next one. Now this example is a little bit different. Now I have negative 5 and positive 2. So let's go ahead and remind ourselves our integer chips. We have negative is red and yellow is positive. I'm going to have negative 5, so I'm going to write it 1, 2, 3, 4, 5. And then I have positive 2, so I'm going to put 1, 2, okay? So now I represented it with integer chips. Now, one thing that you're going to learn now that's very important for you to know is that if you have a positive and negative number, one positive and one negative cancels out. Because think about it. A positive 1, or let me write it right here. Positive 1 and a negative 1, what did we say our opposites do? They equal 0. So here I have a positive 1 and a negative 1. I'm going to cancel those out, and we're going to pretend they don't exist. Same thing here, I'm going to cancel those out, and they don't exist. So can I cancel any more out? No. So I'm left with 1, 2, 3 integer chips, and they're all red, so my answer is going to be negative 3. That is my answer for this particular case. Now, I can also represent it using a number line, so I'm always going to start at 0, and it says I need to go negative 5, so I'm going to use red, 1, 2, 3, 4, 5, and I'm going to jump 5 spots to negative 5, right? So I'm going back negative 5. Then it says I want to go positive 2. So I'm going to start, I ended at negative 5. I'm going to move positively 2 spots. And that is going to end me right here at negative 3. So I got negative 3 here, negative 3 here, and negative 3 here. Okay? So what do we notice when we have, in the last slide, we had 5 plus 2 gave us 7, right? 5 plus 2 gave us 7. What do you think that means? When you have two positive numbers, what is the sign of your answer going to be? It's also going to be positive. So the rule is two positive numbers is going to give you a positive answer, okay? But in this case, we didn't have two positive numbers. We had a mix. We had a positive and a negative. Now, what did our answer end up being? Our answer ended up being negative. What do we notice about the negative 5? In terms of distance and absolute value, negative 5 is a bigger number. So what that means is that when we have a positive number and a negative number, right, the sign is going to be of the one with the greater absolute value, right? So negative 5 plus 2 gave us negative 3. Which one has a greater absolute value, 5 or 2? Well, when I think about walking, right, going 5 steps is more than having to walk 2 steps. So I'm going to look at this negative 5, right? The 5 has a negative sign, so that means that my answer is also going to be negative. Now, are we technically adding these numbers? 5 plus 2, is it adding? Not at all. What we ended up doing was removing the addition sign and pretending to subtract, right? So 5 minus 2 gives us 3. And then we take the sign of the number with the greater absolute value and keep it, okay? That is an abstract rule for doing these integer addition problems. Well, let's go ahead and try some more. Let's go ahead and try this one. So we have negative 2, so I'm going to represent my negatives. And then now we have positive 5, so the sign switched, right? So negative 2 and positive 5. I have these two, a positive and a negative, to cancel, and these two, a positive and negative, to cancel. So I'm left with 3 integer chips, and they all are positive. So my answer is going to be positive 3. Another way that I'm going to represent it is using the number line. So here's my number line, right? I start at 0, and then I go over to negative 2, because that's my first operation. I'm going to subtract 2. Then what I'm going to do is move positive 5. Let me go ahead and write the rest of the lines here. So I'm going to start at 2 and jump 1, 2, 3, 4, 5. That ends me there on positive 3. So using my number line, I can also end up at positive 3. Now let's use the rule, right? The rule when you have a positive and negative number is you subtract, right? So 5 minus 2 gives us 3. So we know that in this case, since we have a positive and negative, we have to subtract it. Which number out of 2, negative 2, and 5 has the greater absolute value? 5, right? Because walking a distance of 5 is farther than walking a distance of 2. What is the sign of 5? Right now, 5 has a what next to it? Positive. So that means that my answer is also going to be positive, right? So let's rewrite this. We have negative 2 plus 5. Is this the same thing as saying 5 minus 2? Right? It's kind of the same thing, because when you think about it, you know how to do 5 minus 2. That gives you 3. And that's the same answer that we got here. So you can also do that where you're rewriting it so it makes sense. So it's written like a subtraction statement. Alright, let's practice this last one. So now it says that we have negative 5. So I'm going to write 1, 2, 3, 4, 5, negative 5. And then we got a negative 2, 1, 2. So now we have a total of 1, 2, 3, 4, 5, 6, 7, right? Negative 5 plus negative 2. And they're all negative, so it's going to be negative 7. Using the number line, we're going to go from 0 and jump negative 5. 1, 2, 3, 4, 5. So I'm going to end up at negative 5. And then I'm going to jump back to the negative side an additional 2. 1, 2. So now I've ended at negative 7. Okay? So that, again, confirms with the integer chips and with the number line that my answer is negative 7. Now, when it was 5 plus 2, we got a positive 7. So we said the rule was if both of the numbers are positive, my answer is going to be positive. So what do you think is going to be the rule for when both numbers are negative? What did we do in this case? Well, 5 plus 2 is 7, so we're going to continue to add, but all we do is just keep the sign, right? So if they're both negative, my answer is going to be negative. Imagine that I borrow $5 from my mom and $2 from my dad. I now owe, which is a negative sign, $7 to people in my family. So that's why when both of the numbers are negative, your answer is also going to be negative. Okay, so what I want you to do now is I want you to take a moment and answer this question in your journal, okay? When you add 2 integers, question A, what is your answer going to be if both of the numbers are positive? Part B says both of the numbers are negative, and then part C says one is negative and the other is positive. Go ahead and write down your response and then show your answer to your iPrep facilitator. Alright, and now you are ready to do the practice problem. So go ahead and do these 4 problems in your journal. I want you to model them using either the integer chips or the number line, whichever one you like better. And then I want you to solve it using the rule. So make sure to model. Step 1, model it. And then step 2 is to solve using the rule. Okay? Model and rule. Once you're done with this, show it to your iPrep facilitator so that they can confirm that you've done it correctly, so you're ready to move on to the next step.